All right, so today we're going to do more with graphing and stating the characteristics of the function. I wrote all these out, so I'm going to go through them real quick. I'm going to take a picture of this and post it with the notes. So you don't have to feel like you have to write this all down. I'm going to post it on Schoology, but let's just pay attention and talk about it real quick. All right, so when you do domain, you want to read left to right. It's smaller numbers to bigger numbers. When you do range, you want to go downwards to upwards. Again, it's smaller numbers to bigger numbers. The y-axis is really just the x-axis turned on its side. Like it's just a number line turned on its side. Parentheses mean you're not including the number. Brackets mean you're including the number. We're doing interval notation. There will be none of the set notation with the little alligator mouse. It's all going to be this, which is nice because it just streamlines it and it's all the same. All right. For your intercepts, X-intercepts are going to be something, comma, 0. Y-intercepts are going to be 0, comma, something. I know that's one more math thing that one of them's one way and one of them's the other. For an X-intercept, you would set the equation equal to 0. For a Y-intercept, you would plug in 0 for X. So the Y-intercept's a little bit easier to find. Because when you set an equation equal to 0, then you have to solve it. So that's like more work. Increasing and decreasing, you have to read left to right. All right. And I do not want to get to the parenthesis versus bracket debate on this. So I go with what they do on the AP Calc exam, because this is pre-calculus, we're gearing up for AP Calc. If it is supposed to be a bracket, but you put a parenthesis, they will still give you credit. If it's supposed to be a parenthesis, but you put a bracket, they will not give you credit. And so I have decided, let's do parentheses for all of those, and then it won't matter. Now it matters for domain and range, but for increasing, decreasing, just put parentheses for all of them. And I checked it on Delta Math on your homework. They accept parentheses for everything. So I was like, just more confirmation that that's a good way to go. All right, relative maximums and minimums. A relative maximum, the graph has to go up and come back down. It's like the top of a hill. Minimum, it has to go down and come back up. That's like the bottom of a valley. It's written the y value at x equals the x value. So it's like 7 at x equals 4. Do you remember that? How it's like kind of backwards? Like, or 3 at x equals -1. This is more of your Hoivux. A horizontal asymptote is y equals, a vertical asymptote is x equals. And behavior, this is going to be new for you. We're going to use the calculus notation. All right, do you remember when you did this? The as x approaches -infinity, where does the function go? Do you guys remember this? Okay, it's the same thing, but in calculus, it's called a limit. So you write lim x arrow -infinity of the function. Its limit as x goes to -infinity of the function. That's the left side. Positive infinity is the right side, and it means the exact same thing as this. Again, I'm going to take a picture of this and post it with the notes. Okay, because I was like, I just would rather you pay attention than have, I know, see some of you writing it down, and that's cool too, but I am going to give this to you. It's going to be posted on screen. So here's what I'd like to do. We're not going to be able to do all of them. I will fill it all in and post it, so you'll have all the answers there. What I'd like to do is graph all of them, and I'll do some of the like harder ones for you. And then with whatever time we have at the end, maybe you guys can like try one with your group. All right. So what is this first function called? Be careful. I know I see the fraction there, but yeah, that's just linear. Rational is going to have the x in the fraction. So this is just y equals mx plus b. So we're going to start at 0, 6. So you go up 6, and then your slope is -1/3. So down 1 over 3. So again, I'm just going to graph them all with you, and then I'll do like some of the harder ones. I put stars next to the ones that I know I want to do here. All right, so what is number 2 called? Okay, that's absolute value. It's going to be a V shape. So transformations for this. It went what direction? So right 5, it's going to be upside down and vertical stretch by 3. So you can go right 5 and put a point. And then because each side of it is linear, you can use the -3 as your slope. So down 3/1. And on this one, let's just do the intercepts. What's your X-intercept? Because you can see it just from looking at it. Good, 5, 0. I know it's one of those things is one goes one way and one goes the other. Here's the common mistake I get on a Y-intercept for a graph like this is people will say that there isn't one. There's going to be, it's just going to be like way down here somewhere. Do you see what I'm saying? Like it's eventually going to hit the Y-axis. You just have to plug in 0 and see what you get. So ready, buckle up, here we go. Plugging in 0. 0 minus 5. -5, absolute value of that, 5 times -3 is -15. So it's going to intersect down here at 0, -15. It's just our graph didn't show that because it didn't go far enough. But it doesn't mean that there isn't one, so don't put none. All right, this one is greatest integer. It moved down 2, so we're going to go down 2 and put a point, so a filled in point. So that's where we're going to start. And then that is a horizontal stretch by 3. Okay, so the steps are going to be 3 units in length. They're still only 1 unit apart from each other, but they're 3 units in length. So the steps themselves got stretched. Again, I really like those ones for showing the stretches and shrinks because I think that just visualizes them really well. We're only going to do domain and range for this one because like there's no increasing, decreasing, maximum, minimums. All that stuff doesn't really apply to a graph that looks like that. Domain is kind of interesting. I know it looks really disjointed, but do you really lose any values as you read left to right? Like where this open circle is, that closed circle picks up. Do you see what I'm saying? Like if you sweep left to right, you get everything. So -infinity to positive infinity. Never put a bracket on an infinity. Infinity is not a value, so you can't include it. And then the range is kind of interesting. You're going to have -3, -2, -1, 0, 1, 2, 3. You just don't get any of like the decimals in between. Do you see what I'm saying? Like you don't get 1 and a half. So your range, and this is really the way you have to write this, is all integers. And it's called the greatest integer function because you don't end up with any decimals. They're all going to be whole number, unless you vertically shrunk it, I suppose. But it's all the integers, which are the positive and negative whole numbers. All right, cool. What is number 4 called? Quadratic, good. And it went down 3, so we're going to go down 3, put a point. And then what I would do is just plug in numbers on either side of 0. Like let's plug in 1 and -1. Spoiler alert, they're going to come out to the same thing because it's symmetric. So let's just try and plug in 1. 1 times 2 would be 2. 2 squared. 4 minus 3 is 1. So we get 1, 1, and -1, 1. So it's really narrow because of that 2. And I always feel like those look like a reindeer. Once you see it, you can't unsee it. Like, like these are his eyes and that's his nose and these are his antlers when it's really narrow like that. Anyway, we're going to do this whole one. We'll do all the characteristics. All right, domain. Well, reading left to right. I know it looks like the arrows are going upwards, but do you get that it's going to spread out this way forever? Yeah, okay. I see heads nodding. You're like, we got it. Well, last year was so disjointed for all of you with Algebra 2, and some of you took it first semester, which was a long time ago. So I'm not trying to insult anyone's intelligence, but I want to make sure we're all together, you know. All right, range, you're going to sweep downwards to upwards. So there's no graph down here. We start at -3, and do we include that or no? Yes, so we want to bracket on the -3 and then onwards forever. So you sweep downwards to upwards, because again, it's smaller numbers to bigger numbers. I'm going to come back to the X-intercepts. We'll do that last because that's going to be a little bit of work. Not a lot of work, just like little work. Okay. Y-intercept right here, 0, -3. Increasing and decreasing, you have to read it left to right. What I usually tell students that struggle with that to do, or even if you don't struggle with it, if it just helps you, label the left side of the graph negative infinity and the right side positive infinity. So reading left to right, what's the graph doing first? Going down, so decreasing probably, there we go. From negative infinity until this point, which is not -3, we're reading left to right, so it's the X value. So 0, good. And if it helps you to label that point, you can do that as well, 0, -3. And then we increase from 0 onwards. So that would be 0 to infinity. So you got to read it left to right. All right, do we have a maximum or do we have a minimum? Minimum. All right, maximum's none. And don't you love that when the answer is none? Like sometimes you get a graph where there just aren't a whole bunch of stuff. It's like none, none, none. All right, and again, this is a good reason to label this point. Your minimum is -3 at x equals 0. And then the end behavior is not hard. You're just going to need to get used to this new notation. It's limit notation. So it's LIM for limit. Limit as x goes to negative infinity of the function, and then limit as x goes to positive infinity of the function. It's actually less writing than the way you used to do it, because it was like a whole sentence sort of before. So it's actually less writing. It just looks funny and that scares people. It means the exact same. And both ends are headed positive infinity. So both sides are going up, so that's positive infinity. All right, let's go back and get the X-intercepts. What you have to do is set this thing equal to 0, and then we're going to solve it. So just in the space that I've got right here, I'm going to take the equation, set it equal to 0, and we're going to work that out. So you have to like do work. It's going to be like 3 or 4 steps of work. It's not going to be a big deal. Okay, but you have to do it. So what would you do to both sides? This is where we're solving. All right, add the 3 over. And then what I would do is square this. So you'd square the 2 and square the x. That would be 4x squared. All right, so we added over the 3 and I kind of like squared what was in the parentheses. All right, then you're going to divide by the 4. So that'll be 3/4. And then how do you get rid of a squared? Good. Does anyone remember what you have to put when you square root? Good. So you get plus and minus square root of 3/4. Now, without a calculator, square root of 3 is just square root of 3. I don't know what that is, but what is your square root of 4? 2. So it's plus and minus square root of 3 over 2. The plus and minus is because you got 2 of them. Do you see here? Like on the x-axis, there's 2 of them. So we get positive square root of 3 over 2, comma 0, and negative square root of 3 over 2, comma 0. So again, it wasn't hard. What was that, like 4 steps? You can do it. I totally believe in you. All right, we're still doing good on time. All right, what is number 5 called? Right, square root. It moved up 4, so we're going to go up 4, put a point, and it's going to go this way, like to the left. The reason I know that is because of the negative, right? So let's make a table of values, and we want to plug in negative numbers, and if we pick something that doesn't work, we will just pick something else. What do you want to try to plug in? Good, I would go straight to -2 as well. So I don't want to deal with a half in there. All right, so if you plug in -2, negatives cancel. Half of 2 is 1. Square root of 1, 1 plus 4 is 5. I'd like one more point. Can we come up with one more number that would work to plug in? And again, if you pick something that doesn't work, we'll just pick something else. Not a big deal. All right, if we do -4, half of 4 would be 2, and square root of 2 without a calculator is not going to work out. So what was that? Good. Let's do -8. Negatives cancel. Half of 8 is 4. Square root of 4 is 2. 2 plus 4 is 6. And so it's going to do something like that. The reason that there's only one line for the end behavior there is because you can only go to the left. You can't go to the right because there's nothing over here. All right, but the rest of that one's pretty easy, so I'm going to leave that for you. All right, next one is called what? Cubic, because of the cube. So this one went right 3. I'm going to put a point at 3. And then I'm going to make a table of values. We want to plug in numbers near 3. Like that's where our center is. So we're going to pick numbers near 3. Now you could go to 4 and 2, but just foreshadowing for you, I don't want to deal with this fraction in there. So I'm going to actually go out a little bit further. Let's do 5 and 1. And I'm kind of guiding you through that, but again, you could pick numbers until you're satisfied with them. All right, here's what you got to do without the calculator. You ready? 5 minus 3, 2. 2 cubed, 8. Good. Half of 8, 4, but it's negative, so negative. We're going to do the same thing with 1. 1 minus 3 would be negative 2. Cubed would be negative 8. So the negatives cancel, and half of 8 is positive. So go ahead and plot this. And it's going to look linear. You just need to remember to make it wiggle. And again, I just want to do the Y-intercept in that because again, the common thing I get is that people put none, and I just don't want that to happen to you. It's eventually going to hit the Y-axis. It's just going to be really far up here. So let's see, 0 minus 3, negative 3 cubed. What is 3 cubed? Does anyone remember that one? I'm going to be impressed, but I want to just throw that out there. 3 cubed, 3 times 3 times 3. Good, 27. It'll be negative though. So negative, or wait, yeah, negative 27. Negatives cancel. So it'll be positive 27 halves. 27 times a half would be 27. So would that be 13 and a half? That's why it went off the grid. It's 13 and a half. And then I just want to do the end behavior for no other reason than to get you used to this notation because I know that it's brand new for you. Limit as x goes to negative infinity of the function. That's the left side. And then positive infinity is the right side. All right, so where's the left arrow going? Up, so positive infinity. Right arrow is going down, so negative infinity. All right, we'll do 7 and then we'll do another brain break. All right, this one is cube root. So it's going to be a wiggle on its side. All right, so it went left 2, down 4. So we're going to go left 2, down 4, put a point. And so our center is at negative 2. So I want to plug in numbers near negative 2. So I'm going to do negative 1 and negative 3. All right, so if we plug in negative 1, negative 1 plus 2 would be 1. Cube root of 1 is 1 times 2. 2. I just want to make sure you're following me through the thought journey. That'd be 2. 2 minus 4, negative 2. All right, and then if we do negative 3, that's going to make this negative 1. Cube root of that would be negative 1. Times 2 would be negative 2. Minus 4 would be negative 6. So again, that's the stuff that you've got to be able to do without a calculator. And again, it's going to look linear. You just need to remember that it's a cube root. And it's going to be this like sideways wiggly. And for this one, we're again just going to do the intercepts. I think that's probably the hardest part on it. So for the X-intercept, it's going to be something 0. You have to take this equation and set it equal to 0 and then work it out. I've got a little bit of space over here, so that's where I'm going to write it. We're just going to take this whole thing and set it equal to 0. It's going to be 4 steps of work. You can do it. I believe in you. Go team. All right, what's the first step? All right, add 4. You're just like unburying the X, basically. All right, and then divide by 2. 4 divided by 2 gives you 2. To get rid of a square root, you would square. So to get rid of a cube root, you would cube both sides. And 2 cubed gives you 8. And then subtract 2, and you get 6. So 6, 0, which makes sense. 6, 0 would be like right about here. Doesn't that look like where the graph's going to hit? Like you can make sure it makes sense. Like if you got -3, you would hopefully be like, oh, that's not right. All right, and then the Y-intercept, you're going to plug in 0. I absolutely love this, and I hope you do too. Some people, this bothers them at first, but then they get used to it real quick. When you don't have a calculator, you just can't do the calculations that you can't do without a calculator. So watch, if you plug in 0 for X, 0 plus 2, 2, cube root of 2, without, that'd be 2 cubed. The cube root of 2 is, I don't have a calculator near me. It's some crazy decimal. So without a calculator, the cube root of 2 is the cube root of 2. So your answer is going to be 2 cube root of 2 minus 4. That's some number. I don't know what it is off the top of my head, but it's some kind of decimal. And you're allowed to just leave it like that. Isn't that awesome? I think that's cool. You can disagree, but I'm right. It is. Like you can just do nothing to, like just leave it like that. Like that's the answer. All right, I'm going to pause the video and we'll do a little break. All right, so what is this one called? All right, good. Rational means ratio. I don't need specific points for this one. As long as you get the asymptotes in the right place, I'm happy. Okay, this one went right 3, so go right 3 and dot that in. And what else did it shift? Up 5. And there weren't any reflections or anything, so it is right side up. Even though those graphs look weirder, they're actually easier to graph because I don't require you to do a whole bunch of picky points. You don't have to make a table. Again, as long as the asymptotes are in the right spot, we're all good. So I'm going to do all the characteristics for this one because it is a little bit tougher. Domain, you're going to sweep left to right. And the way I always say it, I know it's silly, but I'm trying to get you to remember it. Everyone is invited to the domain party except one number. Who is getting not invited to the domain party as we go left to right? 3 is a troublemaker. Leave him out. Kick him out. 3 is a problem. Do you get what I'm saying? Everybody else is there except 3. Here's how you write it. You're going to go from -infinity to +infinity, but skip over 3. And so you need parentheses because you're showing that you left it out. What this means is everything to the left of 3 and everything to the right of 3, but not 3. Don't feel bad for 3. 3 was causing problems. All right, now when you do range, I know you're like, you think I'm so silly, but if I make it sort of funny, then you might remember it better, you know? All right, so if we sweep downwards to upwards, who is not invited to the range party? 5. Kick 5 out, he's a problem. Get rid of him. This is being recorded. So you're 3 and you're 5. All right, I'm going to do the intercepts last because I think those are a little tougher. Increasing and decreasing. All right, look, if you read left to right, what is this graph doing all of the time? Decreasing, perfect. So increasing is none, it doesn't do that. And for decreasing, you can just copy over the domain. It decreases for its entire domain. You can't decrease at 3 because there isn't any graph at 3. You still have to leave 3 out because there's nothing there. So you just copy that answer over. All right, remember Hoy-Vux. Vertical asymptote is going to be x equals, and where was the vertical one? Vertical is 3, so x equals 3. Horizontal is y equals, and that one's at 5. And then go ahead and set up your end behavior. Again, I just want to get you used to this new notation. It's not that bad, though, right? Limit is x goes to negative infinity of the function. Limit is x goes to positive infinity of the function. Kind of interesting with the rational graph because it doesn't go upwards or downwards. And I always get asked, Miss Cole, there are a zillion arrows on this graph. How do I know which ones are the ends? Here's what you do. You take your hand and you cover up the middle of the graph. And whatever's left, those are the ends. So that one and that one. Now they're both leveling off where? 5. It's never going to actually touch 5, but it's end behavior. It's just where is the graph headed? And both ends are headed towards 5. So again, just take your hand and cover up the middle of the graph. Whatever arrows are left, those are the ends. Hold on, we got to go back and get the intercepts. I saved them for last because it's the hardest thing, right? X-intercepts, you have to take this and set it equal to 0. I have some space down here, so this is what I'm going to use. You're going to take that equation, and you want to give the x minus 3 a hug. And set it equal to 0. Keep darkening this up, but it's just silly. All right, so to solve that, you're going to subtract the 5. So that'll make that be negative 5. And then you multiply this x minus 3 over. Do you see what I'm saying? Because I'm running out of space, I'm just going to multiply that to the other side and cross it out. And then what are you going to have to do with the negative 5? Distribute. That'll be negative 5x, bless you, plus 15. It's not hard. It's just like 4 steps of work that you got to do. All right, then subtract the 15. 1 minus 15 will be negative 14. Negatives cancel, and I ran out of room, but you would divide over the 5. So it would be 14 over 5. Don't be scared of the fractions. It's going to be okay. And then for the Y-intercept, you're going to plug in 0. So I've got a little bit of space right above it. I'm just going to write it right here. If we plug in 0, 0 minus 3, that'd be negative 3. So that would be negative 1/3. So we've got negative 1/3 plus 5. And we need a common denominator. So here's the $1 million question. How many thirds is a whole 5? 15. So negative 1/3 plus 15 thirds be 14 thirds. I know you're sitting there hating me right now because of the fractions. You're all going to be okay. It's going to be okay, I promise. It's on Delta Map, so you they have choices you can type in here. All right, 2 more graphs. What is this one called? Exponential. So this one's a swoop. It's going to swoop downwards instead of upwards because of that negative with the x. It moved down 4. So you're going to go down 4 and dot that in. And then we're going to make a table of values. You can plug in whatever you like. And it did not shift left or right. So the center is still 0. So I would start with 0. Let's do that. 2 to the 0. 1 minus 4, negative 3. Let's pick another number to plug in. 2 to the negative 2. Let's do negative 1 and negative 2. You just want to skip over 1. All right, if we plug in negative 1, negatives cancel. 2 to the first is 2, minus 4 is negative 2. This one, negatives cancel. 2 squared is 4, minus 4 is 0. And then when you plot that, you will have your graph. The only characteristics I'm going to do from this one are domain and range. We can talk about the bracket versus parenthesis thing. I think the rest of that is pretty straightforward and you'll be okay. What do you think for domain as we sweep left to right? Yeah, all of everything. You can call that negative infinity, positive infinity, or if you just want to say all reals, that's good, like all numbers. Range, you're going to sweep downwards to upwards. So it's going to be -4 and everything above. But do we want a bracket or a parenthesis on -4? It is a parenthesis. Yeah, why? Because it doesn't actually touch. There's an asymptote. And again, I think the rest of that's pretty, and I'm going to fill this in when I post it, it'll all be there so you can see the answers. But I think the rest of that's pretty simple. You'll be able to deal with that. All right, logarithmic. This is the sideways swoop. This one went left 1. So you're going to go left 1, dot that in. Let's just get the intercepts on here so that we can fill those in and then we won't worry about the rest. Oh, I didn't fill in the name. Logarithmic is the name of this one. You guys all got that right? I'll be thorough and fill it in. All right, so first let's do the X-intercept. I have some space here, so I'm going to write it over here. We're going to set this thing equal to 0. Some of you are panicking already. It's not going to be as hard as you think. Are you still with me? We're good? Your first step would be add over the 2. And what I always tell people with logarithms is when you get stuck, people are like, I'm not going to get stuck this one. Like, yes, you are. By nature of the problem, you will get stuck. Your question when you get stuck is, what is the base? What is the base number? And it's that little subscript. So what's the base here? 2. And I used to tell people think about that Meghan Trainor song, but like the more years that go by, now no one knows what song I'm talking about. Do you guys know what song I'm talking about? It's all about that base. Anyway, I tell them just, when you get stuck, call in Meghan Trainor. Again, if I make it funny, you'll remember it. The base is 2. And it's to the power of whatever it equals. This is your exponent. So it's going to be 2 squared equals whatever's left. So this is the base. This is the exponent. And it's going to equal whatever's the stuff is, whatever's left. So 2 squared is 4. I ran out of space, but 4 minus 1 is 3. So your X-intercept is 3, 0. Told you it wasn't going to be like that. All right, Y-intercept, you're going to plug in 0 for X. So 0 plus 1 is 1. I did bring this up. Let's see who remembers. Log any base, it doesn't matter, of 1 will give you what? There's an automatic answer. 0. Any log of 1 is 0. Nice. Any log of 1 is 0, and then 0 minus 2 is -2. So if you plot those, 3, 0, and 0, -2, then you'll have your graph. And I think the rest of that you'll be okay on. I think that was the hardest one. So I'm going to go ahead and stop the video.